All right, go ahead.
So hello everybody, good afternoon and good morning. I'm Maria, I'm from the University of Santiago de Compostela in Spain, and I would like to talk about one of my projects for my PhD that is called the Phosphoproteomic fingerprint of platelets in obesity, insight into the platelet reactivity. So as all you know, obesity is defined as an abnormal or excessive fat accumulation, and is an imbalance between energy expenditure and energy intake. Indeed, it's classified by the body mass index. The prevalence of obesity represents one of the biggest health problems in industrialized countries. One study performed by some Spanish researchers showed that the 21% of the Spanish population have overweight and obesity, compared with the 36% in states. So obesity is known to be a risk factor for developing other diseases, such as cardiovascular disease, cancer, and diabetes. Indeed, this kind of patient have a pro-inflammatory and prothrombotic state. However, the link between cardiovascular disease and obesity is poorly understood. And here is where platelets could play a fundamental role in increasing this cardiovascular risk. Since obesity has no nucleus, post-translational modification could play a fundamental role in the molecular events leading to platelet activation. For this reason, the main goal of this study is to gain insights into the phosphorylation events related to platelet reactivity in obesity. For this reason, we perform a phosphoproteomic analysis. Here is the clinical characteristics. As you can see, all of them were morbid obese patients, because we like to compare extreme conditions. Then, if you look at the table, you see that the levels of leukocytes are increased in obese patients. However, we see that the mean platelet volume is decreased in this kind of patients. Moving to the workflow, we perform the phosphoproteomics by 4 pools of 3 individuals using biological and technical replicates. We digest 1.2 milligrams of proteins per sample, and the digestion was done by L-fast. Then we enrich the phosphopeptides with TO2. After the enrichment, we identified the phosphopeptides by mass spectrometry using an orbit trap. The peptide analysis was performed by a combination between proteogenesis QI and proteome discover. After that, we check the differential regulated phosphoproteins. We like to know in which pathways were involved. And then we validate the most interesting proteins by target mass spectrometry. So I would like you to know that these samples were performed with resting platelets. So the results were, we successfully identified 964 phosphopeptides corresponding to at least 560 unique proteins. Here we can see the volcano plot. And then I want to comment that only the 22% of all phosphopeptides identified were differential regulated, but it's normal because we are talking about the resting platelets, so these differences belongs to the pathology. So from these differential regulated phosphopeptides, we identified 220. Remarkably, all differential regulated phosphopeptides were upregulated in the obese condition. Moving on, the 220 identified phosphopeptides were originated from at least 175 proteins. Regarding the protein type and the functional time, I would like you to know that most of them were adapters, receptors, and also kinases. Indeed, more than 30% of the proteins were kinases, and only 1 phosphatases. And then most of these phosphorylation are necessary to achieve the full catalytic activity of these kinases. And regarding the functional type, most of these proteins participate in signal transduction upon platelet activation. Also, we checked the canonical pathways alteration, and as expected, the hemostasis was altered. However, we also found that the vesicle-mediated transport and the immunosystem is also altered. So here I perform, well, in order to elucidate what's going on in this pathology, we put all the results together in this picture in order to see which signaling pathways could be altered. If you, we perform this using different system biology software such as Cytoscape, Phosphocyte, String, and also we check PubMed and UniProt. If you look at the picture, we see that a lot of proteins that are hyperphosphorylated in obese patients belongs to the ETAM-related signaling pathways. Moreover, we also found several receptors that are hyperphosphorylated in obesity, such as the TP1B beta from the complex and the beta 3 from the integrin alpha 2B beta 3. Moreover, we also found several proteins that are related with the inside-out signaling for the alpha 2B beta 3, also actin regulation, microvesicle formation, and alpha granule secretion. So then we like to check several proteins that are hyperphosphorylated in obesity by target mass spectrometry. So I don't know if you know, but we found recently that the SARC-mediated signaling pathways is altered in obese patients. Precisely, we found that the residue tyrosine 411, 19 from the SARC is increased in obese patients. This was published in Atherosclerosis last year. So here we found that again that is also increased using another methodology and another cohort of patients. So this phosphorylation is necessary to achieve the maximal activity of SARC. So then we check also the levels by target mass spectrometry, and we found that there are a tendency of increase in obese patients. We have no differences, significant differences, but maybe it's because there are a lot of variability, because there are biological samples, and also because the technique is really hard to be reproduced. So then we also check the PKC theta from the serine 695 that is described that has an enzymatic activity, and we found that is increased also in obese group. Then we also check some protein from the intermediate signaling pathway, that is LAT, that is really important in this signaling, and we check this phosphorylation that it has no function described yet. So we found that is also increased in the obese patients. And finally, we check the VAMP that is belongs to the granulation, and we found that is also increased in obese patients. So all these results validate in a certain way our phosphoproteomic data. However, we would like to do some functional studies in order to corroborate this data. Here we can see the functional studies. We use, again, severe obese patients with no comorbidities that I forgot saying before. We see that the leukocytes is increased in these patients, and also the platelet count, but the mean platelet volume, again, is decreased in these patients. So we check the different receptors by flow cytometry. We perform static addition assays, and also we measure the soluble GP6. So if we found that several proteins are altered regarding or downstream ETAM-related signaling pathways, and also we found several receptors that are hyperphosphorylated in obesity, why maybe is there a kind of alteration in the surface of the obese platelets? So we check these 4 receptors, DP6, CLEC2, DP1B alpha, and integrin alpha 2B beta 3 by flow cytometry. And we found that the DP6 is increased in obese patients. And also we check the levels of CLEC2 in collaboration with the Professor Steve Watson from University of Birmingham. We use a nanobody in order to check these levels, and we found that this CLEC2 is also increased in the surface, in the platelet surface of severe obese patients. Then both receptors correlate positively with the BMA. So then we checked the other 2 receptors, and we found that there are no significant differences when you compare obese patient and their lean match controls. So then, in order to further investigate the sensitivity of these receptors as a potential prothrombotic biomarker for clinical analysis, we performed a ROC curve analysis. And we found that DP6 and also CLEC2 display higher sensitivity to discriminate between obese and lean individuals. Indeed, DP6 display higher sensitivity than CLEC2. Then we check also we perform the static addition assays using collagen and fibrinogen. We perform that using a PMPP substrate that when you add a basic solution, they emit color, so you can measure it by absorbance. And we found that increased adherence to collagen was found in platelets from severe obese patients compared to their lean match controls. However, we found that fibrinogen, they have no differences, so maybe the proteins that we found hyperphosphorylated belongs more that the inside out signaling pathways for the integrin alpha 2B beta 3. So finally, as all you know, DP6 is stable on circulated platelets, but is metalloproteinally seed under condition of platelet activation. So maybe is soluble DP6 increase in this kind of patient. So in order to know the alteration or confirm alteration of DP6, we perform this in collaboration with Professor Elizabeth Gardiner from Australian National University. And we found that the levels of soluble DP6 in plasma were elevated in patients with severe obesity and correlate positively with the BMA. So in order to finish, the take-home message is that DP6 receptor and CLEC2 receptor is increased in the surface of platelets from obese patients. Indeed, obese patient, platelets from obese patients show a hyperphosphorylation basal state compared with the lean individuals. Then there are a kind of DP6 related activation that leads to soluble DP6, and this is increased in the obese patients. So this was in a revision in ATVV. Then I would like to thank, first of all, my group, the Platelet Proteomic group from University of Santiago de Compostela, then also the clinician and the obesidomic group from the hospital. And also I would like to thank my proteomic lab that they host me twice during my PhD in Barcelona. So then also the funding, the government of the Spain government, the Xunta de Galicia, and also the European Union. So thank you very much. And if you have some questions, that's it.
Yay, so good. Another really beautiful story. And, you know, you took that phosphoproteomics and really like got down to molecules, and which is always important. So, okay. We have a question from
I'm gonna I have to share the, because I couldn't see any question, so we haven't.
Yes,
or
you should be able, you can stop your screen share.
Yeah, I'm gonna do it. What can I do? Come on. Nope. Arriba. I think that it's okay. No, I couldn't.
It's okay.
Come
You
on.
don't have to.
Yeah, but I want to.
We appreciate your persistence.
Maybe
I don't know
here.
what it says in Spanish.
I don't know, but
it says like.
Yeah.
Okay, there you go.
My boyfriend is here helping me. Come on. So embarrassing. Sorry.
It's hard when it's in other languages. I only know what it says in English, so.
Yeah, don't worry.
Everyone, Maria is very persistent. All right, so can you see on the bottom of your screen Q&A?
Yeah, I think so. Yeah, I have here one. It's okay. So great job. Thank you, Joe. Do you look at total proteome in addition to the phosphoproteome? Yeah, we have just published this in atherosclerosis. We performed the 2D dyed proteomics, and we found also some kind of proteins that are there related to GP6 and also, well, ETAN related signaling pathways and also SARC related signaling pathways. Indeed, we also found that SARC is hyperphosphorylated and also PLC gamma is hyperphosphorylated upon CRP stimulation. And this is the reason why after that we performed the phosphoproteomic analysis.
Okay, that makes sense. Yeah, so you were like, well, maybe it's more of the signaling than the total protein expression.
Exactly. Yeah, I think that is more like this. So I think that I have no more.
No more. I have a question though. I know you're leaving, but like, if you were staying, what would be your next experiment?
Yeah, I would like to work with megakaryocytes, you know that. So
but I think in that lab, like, what do you hope your replacement does?
Well, I'm really interested on the why kinases are increased in obese patients because it's really, really interesting that more than 30% of the whole phosphoproteins that are upregulated are kinases, and most of them have this induced activity. So maybe there are kind of hyperphosphorylated from the kinases. So maybe I dip into that, and also I would like to continue with a diet-induced rat model or something like that, because we perform some small procedure. So maybe I could dip into that, or maybe change to mice or something like that, in order to know knockouts from GP6, or maybe, yeah, I will move in that way.
Yeah, it's interesting, a lot of the lipid stuff. So, all right. Thank you so much, Maria. And
thank you very much.
Luck on your Viva. You're going to do great.
Thank you very much. Bye.
Bye. All right. Leading to our last but not least, never least, speaker. Thanks to everyone for sticking around. There we go. I'm going to stop recording.